Hello friends, we are from Walchand College of Engineering Sangli and we are presenting our EMF project of Slayer's Exciter under the guidance of VP Mohale sir. Requirement of the project. First, transistor PN2222A. Second, a LED. Third, 22 kilo ohm resistor. Fourth, enamel copper wire gauge 8 to 30. Fifth, 9 volt DC battery. Sixth, plastic pipe length 8 to 10 inches and diameter half inches. This is the circuit diagram of our circuit. The several parts that makes up this layer circuit are: first, the battery supplies the voltage and the amperage to the circuit. The biasing resistor and the transistor forms the driver circuit which prepares the coil for transformer action. Second, the primary coils creates a magnetic field from the electricity. Third, the secondary coil converts the magnetic field back into electricity and steps up it to a much higher voltage. Working of this layer experiment circuit. When 5 to 8 volt is fed into the circuit, a resistor R1 is placed before the base pin of the transistor in order to limit the amount of current the pin receives. If too much current is uh, if too much current is allowed into the base pin, the resistor can produce excessive heat and fail. Second, one end of the secondary L2 is connected to the base pin of the transistor in order to feed it with oscillations. The LED is used to prevent the oscillations from going directly to the ground. Third, when the base pin receives a little bit of current, it closes the circuit and electricity it allows to flow through the primary coil L1. When electricity likes to take the path of least resistance, so when the electricity is allowed to flow from the collector to the emitter nearly 0 ohm resistance, it will stop flowing to the base because there is 47,000 ohms of resistance there. When the electricity stops flowing to the base will open up the circuit again until the resistor offers least resistance than collector emitter path. This cycle repeats itself many times a second. Fifth, the primary coil collapses when the electricity stops flowing through it. When this happens, the secondary coil picks up the magnetic field and converts it back into voltage, which gets stepped up to around 1000 volts in the process. The top load acts as a capacitor and increases the output from the secondary, causing the electrons in the air to become excited. Finally, the oscillations from the secondary coil are fed back into the transistor in order to tune or achieve maximum output from this layer circuit. As you can see, the bulb is glowing. As you can see, our project is working. The air near the Tesla coil is excited when we place our bulb near in the field. The neon gets excited and glows up. As you can see, the bulb is lightly glowing. The LED indicates the working condition of our circuit. During the working of the circuit, we must take the precaution that this layer exciter creates an electromagnetic field that may negatively affect electronic equipment near the circuit. Also, we should not touch the circuit while working. For the erection of our project, the overall cost of the project is 330 rupees. Also, the point to be noted that the primary winding on the secondary winding must not reverse, otherwise the circuit will not work. Thank you.